If you want to start building web applications in .NET, learning ASP.NET Core MVC is the perfect first step. While frameworks like this can seem confusing at first, this tutorial will help you understand the fundamentals in under 30 minutes. In this video, we'll cover the MVC architecture, explain the role of each file when you create a new project, and demonstrate how models, views, and controllers work together. We'll also explore essential concepts like IActionResult, action parameters, and eraser syntax. By the end of this tutorial, you'll have all the foundational knowledge you need to start creating the web applications you want. Well, welcome to Code the Future. My name is Island, and my goal here is to help you learn C# and .NET on your own. Now let's dive right in. I'm going to explain to you what the MVC architecture is in programming, and I'm going to walk you through everything you need to know. MVC stands for Model View Controller, and it is an architectural pattern that divides an application into three primary components: models, views, and controllers. This separation helps achieve a clear division of concerns in our applications. Separating concerns or responsibilities in MVC makes the application easier to develop, debug, and test because each part, either the model, the view, or the controller, has a specific job. When responsibilities are mixed, like combining user interface and business logic, changes to one can affect the other, making updates and testing harder and more error-prone. For example, user interface logic changes often, so if it's combined with business logic, you'd need to modify and retest both every time the interface changes. Now let's see each of these components in more detail. The model in MVC represents the information or the data the application operates on and handles the logic for processing this data. For example, if you have an application for managing books in a library, the model would represent the data about the books and the rules for adding, updating, or removing books from the collection. A view in MVC is the part of the application that displays the data to the user. A controller then manages user input and interaction, determining which model types to work with and which view to render, effectively controlling the application's response to requests. You need to know the contents of each file in your project when building anything in programming. For this reason, I'm going to explain to you concisely the role of all files you have when you create an MVC web application project in ASP.NET Core. To create our first application, we can just open Visual Studio and click on Create a New Project. Next, find an MVC template for a web application and make sure that C# is the language for this template, not F#, for example. In the page that loads, give a name to your app, like My App. You can change the location where you want your project to be stored if you want as well. Click on Next, and here I will select the .NET version to be .NET 9, this preview version, but the final release of .NET 9 may be available by the time you watch this tutorial. Let's leave all the other settings as they are for now and just click on Create. Here we have our application. When you create a new ASP.NET Core MVC project, several key files and folders are automatically generated. Let's go through them one by one. First, we have the program.cs file. This is the entry point for the application. This first line initializes a new instance of the Web Application Builder class, which sets up the configuration, services, and the web server. Next, we add services to the dependency injection container. Here we are adding MVC services to the container with support for both controllers and views. This allows our application to handle incoming HTTP requests and render HTML views. Then we build the application. This line compiles the app, creating a web application instance, which you can then configure and run. Now we configure the HTTP request pipeline, which determines how requests are processed by the app. If the app is not in the development environment, we set up an exception handler to redirect users to the home/error page when an unhandled exception occurs. Additionally, we enable HTTP strict transport security to enforce secure HTTPS connections. We continue configuring the pipeline with this app.use HTTPS redirection, which ensures that HTTP requests are redirected to HTTPS, and app.useRouting enables routing, which allows the app to match incoming requests to the appropriate endpoint. Next, we have the app.useAuthorization, which is responsible for authorizing users to access secured resources. We map then static assets. This line enables serving static files such as images, CSS, and JavaScript from the www.root folder. Then we configure the default route for the MVC application here. This sets up the default route pattern, which maps to the home controller and its index action method by default. The ID parameter is optional. So this is the default route that will be redirected to when we start our application. Every URL is actually assumed to have this pattern. The first part is the controller, then a method of that controller, which is actually called an action in ASP.NET Core, and the ID that is optional. Let's say a request is made to a URL called /items/overview. Our application will try to call an action called overview inside an items controller. And now let's go to the last line. Finally, we run the application. This line starts the web application and begins listening for HTTP requests. Now, let us now see what the other folders do as well. If you want a guide for your next step as a C#/.NET developer, you can get a free roadmap outlining what you need to learn and in what order. By signing up through the link below, you'll also gain access to my 3-day developer growth challenge, which is going to give you momentum and help you improve as a developer. So sign up using the link below, and now back to the video. The controllers folder contains the controller classes. These handle incoming HTTP requests, process user input, and interact with the model to return the appropriate view. For example, we have the home controller here that is already created. The models folder then contains classes that represent the data of the application. Here we have a sample model, errorViewModel.cs, which is used for error handling. The views folder contains the eraser view files, or the .cshtml files, used to render HTML to the client. In this folder, you'll also find the view imports.cshtml, which contains directives that are imported into every view, such as tag helpers, and the underline view start.cshtml, which specifies common view configurations like the layout. Within the views folder, there's also a shared subfolder, which contains shared views like the layout, which is the layout page that is used as a default design for all pages, and this underline validation scripts partial.cshtml file, which contains client-side validation scripts. There's also a home folder, which contains views related to the home controller, such as the index view page and the privacy view page. The www.root folder is the root for the application's static files like CSS, JavaScript, images, and other assets. Inside, you'll find subfolders like CSS for style sheets and JavaScript for JavaScript files. For example, site.css and site.js are default files included for your custom styles and scripts. Next, we have the configuration files. The app-settings.json file is the main configuration file for the application. It contains settings like connection strings and app-specific configurations, which we'll see later on. Let's take a look at the properties folder as well, where we have the launch settings.json file that contains settings related to how the application is launched during development. They can be modified to suit the specific requirements of the project or different development environments. And that's a quick overview of the main files and folders in an ASP.NET Core MVC web application project. I'm going to show you the basics of ASP.NET Core MVC using .NET 9. We will see how to work with the models, the controllers, and the views, and how they interact with each other, all in this short video. If you're new to MVC, this is the perfect starting point. I'm just going to go to the models folder and create a new model, or basically a new class for the models. I'll name it let's say item.cs, we'll see that a simple class will be created. Now, this class represents the data of our application. If we were to store this, which we'll do later on, in a database, this class that's stored in the models folder will represent a table in our database. And each property that this class will take will represent the different columns that the table will contain. So we can give to this class different properties. Let's say, let me just give it an ID property firstly, and I'll explain everything. So basically, we're setting an access modifier to public for this property so that it can be accessed outside the class. The ID, we name the property here, and it will be an integer. This is the type of data. And here we have a getter and a setter that allows this property to be accessed outside of our class. So this is an auto-implemented property. This is just some C# theory here. We can specify here different properties for our model, and we give each item an ID. We can give also each item a name. I'll set it to be public string. The name will have the data type of string. I'll name it name, and the getter and setter as well. Now let's say we want to access this item in a specific URL pattern. Let's say that it would be /items/ let's say overview. So we'll create this application so that when a user makes a request to this URL, it will be redirected to a page that gives him the item. For this reason, what we're going to need is we're going to need a controller named items and also an action in that controller named overview. Let me just go to the controllers folder and add a new controller. I select an empty template here, click on add. I'll name the controller to be items controller. And we'll see a simple class here, an items controller, the items controller class, which inherits from a base controller class. Basically, every controller will inherit this base controller class because it inherits multiple methods, but you do not need to worry about this for now. We can see, as we talked before, each method in a controller is called action in ASP.NET Core MVC. And here we see this index method, or this index action here. This is a public method. It returns an IActionResult and it's named index. I'm gonna clarify to you in the next section what IActionResult means in more detail, but basically this just allows our method to return different types of things. In this case, we are returning a view, which is actually included in this IActionResult return type. But as I said, we'll talk about the action parameters and action result types in the next section. For now, what we'll do is that I'm gonna actually change the name of this action to be overview. Since we wanted the user to be redirected to this specific route. And I'm going to take an instance. I'm going to create an instance of the model that we just created here inside this action. Taking a variable, naming it item equals to new item. And I'm going to need to import the model on top of the controller so that the controller knows the model basically that we created before. So I'm going to need to use this using directive, the name of the application, .models here. And as you can see, this item keyword is now in green because the page recognizes what it means. And let me just create one item here. It's not necessary for me to give an ID to the model because the program will give it itself. So I'm just going to specify for the item the name property. And let's give a name to a random item. Let's say keyboard. And that's it. So I have created an item here and I'm going to pass it actually to the view so that we can be able to render this item that I created here inside the view that we'll basically need to create. What this action here does is that it creates the item, it renders the view, but we're going to need to create the view because we don't have a view named overview yet. You can just go to the views folder. We're going to need to actually create a folder to store all of the views inside the items controller. For this reason, I'm going to name it items. And inside this items folder, we can store views for each action in this controller. And for our case, I'm creating an empty view and I'm naming it according to the name of the action, which was overview. And here we have our overview CS HTML page. Here we can write the plain HTML code that will be rendered to the user, but we can also embed here C# code, which we'll see in a bit, what we want to store in this page. I'm actually writing a HTML paragraph here, and I'm going to display to the user, this is the name of the item. And for me to actually access this item model that we created inside our controller here, that we put as a parameter in the view, I'm going to need to import the specific model on top of our view page. I'll do it by just writing this @ model and then the exact address of the model that we created, which is the name of the application, .models, the name of the model, item. And now I can access the item that we gave into the view by just writing this @. The @ we'll use a lot. This is how we basically write C# code inside our view pages. And for me to access the model, I need this model keyword and @model. And here I can access the ID or the name of our model. I'm going to access the name here in this case. And now if we run the project, let's see what we have written now. Now, this is our home controller, the index page, the default route of our application. So this is what we'll see here. But if we go to /items/overview, we will be redirected to the items controller, to the overview action, which will actually render our overview view page. Let me just hit enter and we should see here, this is the name of the item and then the name of the item which we specified by using this C# code in our view page. So this is just the basics. It may seem a bit complex right now, but you have worked with models, controllers, and views all in this short video. I'm going to explain to you what IActionResult is in ASP.NET Core, why we use it, and I'm going to walk you through everything you need to know. In the previous section, we saw inside our controller that the actions return this IActionResult. But what is the IActionResult? IActionResult is an interface that basically defines a contract for all the different kinds of results that an action can return. Inside of an action, we can return to the user different results. We can return a page, we can redirect the user somewhere, we can return a JSON, just a simple message, and so on. All of these different action results derive from the IActionResult interface. In some cases, we may have a condition inside our action which would return different information to the user depending on specific requirements. And in this case, for us to include each of these different return types in the return type of the action, we specify here IActionResult instead of just specifying, let's say, view result or content result, so that it includes everything that the action can return. Let me just remove this and show you what we could use if we didn't use the IActionResult. If we would want to just return a view, let's say we can just return here a view result and then return the view here. Actually, the view that we are returning here is just a helper method that is inherited from the controller class, and it's just a shortage of this view result. The long way of writing it would be return new view result, but as I said, This is a helper method that allows us to write it in a more flexible and short way, and this is the way you will mostly see it in the code or from the documentation. So we could return different kinds. We could also return other kinds of information inside a action. We could return content result. Here I can just write return content. Content is as well a helper method. Here I can just write a message to the user like hello there. We can return just JSON result, a redirection result, and so on. But every of these different result types inherits from the IActionResult. And as I said, that's why we basically just write on top of as a return type of every action IActionResult, so everything is included in it. I'm going to explain to you what action parameters are in ASP.NET Core and the different kinds of them. I'm going to walk you through some examples as well so that you'll learn how they work. So let's get started. Action parameters are a way for our actions to receive input data. This input data can come from different sources such as URL segments, query strings, form submissions, or even a combination of some of these. Let's just start to see how the URL segment parameters work. In our items controller, I'm just going to create a new action. So public IActionResult. I'm actually going to name it edit. And here in this action, I'm going to receive an int ID parameter from the URL. And in this case, the parameter is passed to the action directly from the URL depending on the route configurations of our application. If you remember in program.cs, the default route pattern here is specified and it actually allows us to receive an ID parameter. Okay, so let's go back to the controller. And I'm just going to return on the screen some content. I'm going to write here return content, and I'm just going to return basically a message on the screen. So I will return the ID. Then I'm going to pass here the value that we get of the parameter that we get from the URL. Let me just run our project. And if I go to this specific route to items, the name of the controller, slash edit, slash, let's say 231, whatever number you want, we'll see that the parameter is passed to the action from the URL directly, and then we have displayed this parameter on the screen. So we can see here that the ID is equal to 2. Now let's just see how the query string parameters work. So query string parameters are this part in the URL that comes after the question mark, and they are usually used to filter or to sort. This method is usually used to filter or to sort data actually. Let's just see here how it works. So after the edit part, we'll input here question mark and give the ID the value of, let's say, 4. Click on enter and we can see on the screen that the ID has the value of 4. So the parameter is passed from the query string to our action, and we see here the value of the ID on the screen. Now, another way would also be, as I told you before, to take data from form submissions, but do not have the necessary knowledge yet. So I'm just not going to take an example for it. And one last thing I wanted to mention is that if we would actually change the name of the parameter we take from our action here, let's say change it to item ID, we would be able to still get the data from the query string, but we would not be able to take this from the URL segment, just because in the program.cs file here in the pattern of our route, we have specified that we can take from the URL can take an ID parameter and not an items ID parameter, so to say. So if I just go back here, run the project, let's say if I go to the route here, items slash edit, and I write this query string items item ID equals to 5. We should still see the value of the ID printed in the screen, but if I would do it using the URL segment, like edit/7, we would see that the value of the ID would default to 0, just because we are not taking the value from the URL in this case. Razor is a markup syntax used in ASP.NET Core to embed C# code into HTML. It's designed to be clean and concise, making your code easier to read and maintain. You'll commonly see Razor syntax in views, which are responsible for rendering the UI. Razor syntax is denoted by the @ symbol. Now let's look at some common uses. First, let's start with basic variable embedding. Suppose we have a variable that we want to display in our view. In this example, we declare a variable message inside this code block that we can write inside our view pages and use the @message syntax to embed its value inside a paragraph tag. Razor also supports embedding more complex expressions and C# code blocks. For instance, let's loop through a list of items and display each one of them. Here we use the @forEach loop to iterate over a list of items and output each item within a list tag. Notice how we seamlessly switch between C# and HTML. Razor syntax also includes conditional statements, which are useful for rendering different content based on certain conditions. Let's see an example with an if-else statement. Depending on the value of the isLoggedIn variable, Razor will render either welcome back or please log in. This makes our views dynamic and responsive to the application's state. Now let's talk about the Razor directives. Directives are special instructions for the Razor engine, and they're prefixed with the @ symbol. Some common directives include @page, @modal, and @using. For example, the @modal directive specifies the type of modal data the view expects. This is crucial for strongly typed views. In this example, the @modal directive is used to indicate that this view expects a myViewModal object. We can then access the modal's properties using @modal. Lastly, Razor has a feature called tag helpers, which allows us to dynamically add behaviors and attributes to HTML elements. Tag helpers make our Razor views cleaner and more maintainable. Here's a simple example using the ASP4 tag helper. The ASP4 tag helper binds the input field to the name property of the modal. This ensures that the correct value is posted back to the server when the form is submitted. If you want to keep learning web development in ASP.NET Core MVC, you should watch the rest of my full beginner course, which should be on the screen right now. So click on the screen to continue. Thank you so much for following along this far, and I'll see you next time.